A platoon of soldiers is on the march through the rugged hills of the Sahyadri range. It's the middle of June, and the humidity of the dense jungle combines with the 40-degree temperature to create an experience these young men will never forget. The march has been devised by their instructors to push them to their absolute physical and mental limits. In the jungle, as they work past each bend, gully, and ravine, as their joints try to cope with ground that seems forever broken and tilted, as fatigue builds up mercilessly with each step in the still, dank jungle air, these soldiers need only look back to see their starting point clear as crystal. After 7 hours of this punishment, legs are cramping, shoulders are red and raw from the straps and sweat, 2 men have already fainted and been revived. And yet, they can still see the place they started out from. It seems to be close enough to toss a stone at. This is not coincidence. The instructors training these men selected this route for maximum psychological strain, and they used their understanding of distance and displacement to do so. But what is the point of this exercise? Why do these soldiers, many of whom have never studied physics, need to learn the difference between these two concepts? Let's go on a journey together and find out. In physics, the separation between 2 points and the path taken to move between those 2 points can be completely independent of each other. In this example, an ant crawls across a surface starting from a point, let's call it A, turning this way and that, but ultimately reaches another point B. We can ask 2 questions. Number 1, what is the length of the actual path that the ant crawled to get from A to B? Number 2, what is the separation or shortest distance between points A and B? In physics, these 2 quantities are equally important for different reasons. The length of the actual path walked by the ant is called the distance covered by the ant, while the shortest distance between A and B is the displacement between those points. Coming back to the soldiers in the jungle, the route planned out for the soldiers was intentionally maximizing the distance that the soldiers must cover, while at the same time minimizing the displacement of the soldiers from their starting position. In actual war, the displacement of the soldiers from the enemy is more important than distance covered, because the enemy may be able to track them in a straight line from the air and thus be able to find them very easily. Even in everyday physics, the difference between distance and displacement becomes important. Consider this spring fixed to a support. In order to move the weight, we must stretch the spring. As we move it on a frictionless surface, we must perform work. However, the change in the potential energy of the spring depends only on the separation of the tips of the spring and is independent of the path taken to get to a particular position. On the other hand, the amount of energy consumed by a car moving from point A to B is dependent not on the separation between the points, but on the length of the actual path that was covered by the vehicle. In addition, we must remember that while distance is a scalar quantity, displacement is a vector quantity. In other words, distance can be described completely by its magnitude alone, but displacement needs you to determine magnitude as well as the spatial direction of the final point in relation to the initial point. Now that we understood the distinction between distance and displacement, let's delve into more complex ideas.
Manorama Horizon. Learning made simple.